grade 10s. We have a test on Friday. Today I'm going to chat briefly to you about interpreting graphs on page 481. And then you have class time to do some studying and review today. And then all of our class tomorrow is study and review, test on Friday. Okay. So today's lesson is like a lot of review from like prior knowledge of just math in general. Like you have done stuff like this in grade 7, 8, and 9. So we're looking at this graph to start off with. The graph is representing the amount of fuel in liters of a gas tank on day 1 of a family's journey. So notice on the bottom is our time of day, our x-axis, and our y-axis is the amount of fuel in liters. Couple things to note. First off, it's 24-hour clock on the bottom. So I think it's helpful because we're not as familiar with 24-hour clock, but often graphically that's what they'll use, is I would fill in your x-axis just to kind of help you. So this would be like 800, 900, 1000, 1100, but then it's actually like 1300, 1400, right? 15, 16, 1700. So this would be like 5 p.m. just to help you out. That's like, I'm just doing this if you need it. Personally, I always struggle with 24-hour clock. Like it's just an extra pause. So it's kind of to take that away initially. So looking at our graph, remembering we're talking about a journey, what's happening between points A and B? So this first chunk of time, who can tell me what's going on in that chunk of time for that first initial? Carissa. Good, right on. Talking about like driving, I'm looking for some specific words. So it's at a constant rate. So likely we're driving at a constant rate. I would take like your fuel's decreasing at a constant rate, but that constant word is pretty key. And then specifically that's over 3 hours. You just said over a period of time. That's fine. Answers here, I get that there's like a range. You want, if it's at a constant rate, like that angle is the same the whole way through, you should keep it, like keep that word constant. For our purposes, most of the time it's going to either be obviously constant or very clearly not. Okay, between B and C, what's happened likely between points B and C? Go ahead, Matt. Good. Good. The fuel's not changing, right? We're talking about fuel. So likely, if you're stopped on a road trip, what are you likely doing? Eating, going for a break, something like that. And that was for, I think, 30 minutes. So notice the question said a reference to the journey. So we're really specifically talking about the journey, what's happening on this road trip. Okay, between points C and D. So we have this drastic jump up here between points C and D. What would have happened between points C and D there? I've heard from both of you. Someone else that's new. Carissa. You're not Carissa. Charlotte, sorry. I did. Charlotte, sorry. Good, they're refueling your car, totally, right? My gas tank's going from, what is that, 20 all the way back up to 60. So it's a drastic increase. With this graph, our x-axis is per hour. Time does pass while you fill up a gas tank, right? Like there is a period of time there, so that should ever so slightly be at an angle, but it takes like minutes to fill up a gas tank, so that's why we probably aren't seeing that angle. So they're refueling. For those of you just getting here, we're on page 481. So physics is going to start coming into play within some of these questions. So what is the rate of fuel consumption in liters per hour? So whenever you see per, that's division. So we just really want liters divided by hours between D and E. So let's start off by finding points D and E on our graph. So point D right here is at like 1030 and 60 liters. Point E would be at 1330 and is that 25? 25 liters, does that look right, guys? Sure. So for something like this, you can show your work a lot of different ways. So our liters, I'm going 60 minus 25, which gives us 35 liters. And then we went from 1330 and 1030, right? Is that right at 1400? What do you guys think? It's hard for me to see this on the computer. 1400 it should have been. So 3.5 hours has passed. I will give you a more precise graph so you guys can see grid lines, just so there's not more wavering. So then we're going to do our 35 liters divided by our 3.5 hours, which gives us 10 liters per hour. Which line segment represents the car being refueled for a second time? Good. Do alphabetical, GH, like as time passes, it would hit G first and then gone up to H. So GH, they refuel a second time. Our gas tank gets filled up. Part D, calculate the total time the car is being driven. Few different ways you guys could do this to like count it up. At the end of the day, they started at 7:30 and they started at 7 o'clock and they went to 1700. So because it's in 24-hour time, that's pretty easy to see 10 hours total was their day. But they took breaks. How many breaks did they take? So their first break was for 30 minutes from B to C. And then their second break is it an hour? From E to F. So that gives us 8.5 hours of driving. You guys can calculate this in a lot of different ways. Like if you just want to read your graph, I wouldn't mark on these questions like what work and things like that you're showing. E, if fuel costs 85 cents per liter, calculate the cost of fuel used for the first day of the journey. First off, 85 cents. This book is clearly really old. What's gas at right now? Thank you. It's over $1. It's like $1.03, $1.04. You know, at gas stations, gas is always posted in cents. So it'll be like 103.95, 104.95. At times this year, I think it's dropped into like at the very beginning of COVID when it first hit, gas was super cheap right then. And we got down into like 90 cents. This workbook is super old for it to be 85 cents. I don't know. It's old. Like I told you, I use the same workbook. They have not reprinted it for a very long time. 2006? Yeah. We were in grade 9. Born. Yep. Okay, fuel used. Let's go through that. So from points A to B, the gas tank started at 50 and then dropped down to 20 liters. We don't care about B to C because no gas was used from there. C to D was refueling, so then we have D to E. They went all the way up to 60 and dropped down to 25. Then they stopped again, took another break, so then F to G, they used from 25 liters, went down to 15. And then our last chunk of time is H to I, which they use 60 to 50 liters. So A to B, that's actually a difference of 30, difference of 35, difference of 10, and difference of 10. So that's 65, 75, 85 liters in total. How do I figure out how much it costs me if I know total liters used and cost per liter? Go ahead.
You just need to look at the gas.
So we want to find our total cost. So we're going to take our 85 liters they used and we're going to multiply that by, I'm going to convert it to dollars because we're going to have a dollar amount here in the end. So 85 cents per liter. Have you guys done unit analysis yet in science? Yeah, no? So we have liters on top and liters on the bottom. Like converting from like micrometers to nanometers. Have you done that? A little bit. So right, 5 liters on top and liters on the bottom, they cancel out. At the end of the day, we're going 85 times 0.85, which gives us $72.25. Which for driving 8.5 hours, that's really good. Okay, turn the page. We're just going to chat about these next couple of graphs. So a lot of this section, I think this math is pretty simple math. That being said, we're talking in like generalisms here because there's not a ton of information given. So your answers here, there's a range of answers I would like take in or accept. So the first graph they gave us is speed versus time. That being said, we don't know what the units for speed are, and we don't know what our units for time are. So you could be talking in this first example in kilometers per hour. Like say we're driving again, so our time would likely be in hours. But your speed could also be meters per second, right? It will vary. With speed, this first chunk of my graph has a plateau or a straight line. What does that mean regarding speed? Good, I'm going at a constant speed. Cruise control's on, perfect. If I'm running at a constant speed. Second chunk of time is a downward angle. What does that mean with regards to speed? Good, I'm slowing down. You're decelerating would be like the technical term. Slowing down, good. Slowing down at a constant rate. So if we're driving here, I'm slowly coming down, like the speed's going from 110 to maybe an 80 zone. So I'm slowly going to adjust to that at a constant rate. I'm not like hitting my brakes hard at like a red light, for example. Then again, I'm going to go at a constant rate. So now I'm in whatever speed zone. What's the upward angle mean? Good. Increasing, I'm accelerating is the word we often use. I get to whatever constant speed I want to be at again. And then lastly, we decelerate until we stop. You're telling a story with these questions. I didn't write this out because that's a lot of writing, and I feel like we don't need to write out what I'm saying. Go ahead, Gavin. Yes, that's just differentiating. I ran out of colors. Is that better? Okay. On this next one, we still have speed versus time, but now we have these arcs. So likely maybe this is like someone sprinting and running or something like that, this scenario. So like I'm speeding up and then I'm slowing down. Speeding up, slowing down. Speeding up, slowing down. You're telling some sort of story with these types of questions. It's very general. Okay, let's go down to the next example down here. So then we're going to ask you to draw a graph. Baking temperature. So we're baking a pie. We have oven temperature in Celsius, time in minutes. What like key temperatures would you think you bake a pie at? Ish. 350, 375, probably something like that. So pretty high up. What temperature do you think your house is? Okay, so like way down here. Right? Our oven isn't starting at 0 degrees Celsius because our house isn't at 0 degrees Celsius. When you bake a pie, you have to preheat your oven first, right? That takes time. So there's going to be a period of time where my graph is slowly increasing up to my 75 mark. Bake my pie for 30 minutes. And then you're going to turn your oven off and it's going to cool down again to about the 20 degrees. And then realistically after that, you could draw the line continuing forever because then it's just at your house temperature again. Question like this, if you didn't remember that there's like a house temperature and you started at 0 degrees, I'd probably give it to you because that's something I don't expect you guys to like necessarily think of right away. Very easy to start at 0. Okay, so let's say Ben is taking part in a 100-meter sprint. So we have speed versus time. How long does it take to run 100 meters? Not very long. You have a really quick speed initially, and then hopefully you're fairly consistent, and then you fairly abruptly stop at the end, right? So initially we speed up really fast, run your 100 meters, and then you probably slow down and stop. You're gonna have a very clear endpoint because once you stop running, you are like standing. Again, these questions, like, we're generalizing them, I get that, right? Like, if you want to tell me your little story, your stories each could be a very different story. Yeah. I think I have to include one because it's the curriculum.
Just like say like the stories are from Link.
So only 2 questions you have to do are 7 and 8. Then I have a review booklet for you to be working on. I still have to make the solution key for it, so I will be doing that as you are working. Only 7 and 8 you have to do though, and then we're studying for the rest of the class. No, you're not going outside. 8.